This video is prepared by Aavya classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIIMS and NEET. And first problem I have picked from AIIMS 2011. It is assertion region based. And assertion is magnification of a convex mirror is always positive, but that of the concave mirror may be both positive and negative. And reason it depends on the sign convention chosen. So assertion is true as the magnification of convex mirror is always positive. However, if in case of concave mirror, it may be both positive or negative. Like for convex mirror, if M is positive, then it's true, and it means image is virtual and erect. So clearly we have learned all this concept in the convex mirror. And for concave mirror, it's always M is positive always. So for concave mirror, if M is positive, so M is positive in the case when the object is placed between the focal point and the pole. And if M is positive, then it's a virtual and erect, image is virtual and erect. And if M is negative, which is true for all cases except the image is placed between focal point and pole, so its image is real and inverted. So clearly assertion is true that magnification of convex mirror is always positive, but that of a concave mirror may be both positive or negative. However, the reason says that it depends on the sign convention chosen. So reason is also true, but reason is not the correct explanation of this assertion. So clearly both A and R are correct, but R is not correct explanation of A. Now we will see problem number 2. An object 5 cm tall is placed 1 meter from a concave spherical mirror which has a radius of curvature of 20 cm. The size of image is, so it's a easy problem. You can simply apply the formula that magnification M is I by O, and it is equal to F divided by F minus U. Here F is given as F is the radius of curvature divided by 2, that is 20 by 2, it's a 10 centimeter. So F is 10 centimeter, and as this is a concave mirror, so if you see it's a concave mirror, so it comes with a negative sign. Like in case of concave mirror, the focal length F comes with a negative sign, so F is minus 10, and U it's given 1 meter, so it's minus 100. So it's minus 10 divided by 100 minus 10, and from there we get minus 10 divided by 90, that is minus 1 by 9. So clearly the image I is equal to minus 1 by 9 into O. Here O is 5 centimeters, so minus 1 by 9 into 5, that is minus 5 by 9, and it is equal to minus 0.55 centimeter. So the size of image is minus 0.55 centimeter. So clearly you can see that the object seems to be very far away from the pole, and the object rays are almost parallel, so the image will be formed near the focal point, and the size of image is very diminished. Now the third problem, the minimum distance of real image of an real object formed by concave mirror of focal length f from the mirror. So it says that the minimum distance of real image of a real object So it says that what is the minimum distance between real image and real object in case of concave mirror of focal length f. So as we know that if the object is placed at the center of curvature, then its image is formed at the center of curvature, and it is inverted image. The size of image is equal to size of object, and in this case u is equal to minus 2f and v is also equal to minus 2f. So clearly in this case the minimum distance between the object and its real image is possible, and it is equal to 0. So answer will be 0. Option A is correct. Now if you see the problem number 4 is based on the same concept, that what is the minimum sum of distances of a real object and a real image from a concave mirror of radius of curvature equal to 20 centimeters. So the minimum sum of distance of a real object and real image is possible when the object is placed at the center of curvature. So in this case also the sum of distance is equal to u plus v. So you have to calculate the minimum value of u plus v. So u plus v is possible, that is when u is equal to v is equal to 2f, and in this case that is equal to r, and it is given as 20. So clearly the minimum value of u plus v is equal to 40 centimeter. And if you see the option, then option B is correct. The minimum sum of distances of a real object and real images from a concave mirror of radius of curvature of 20 centimeter is 40 centimeter. Now the next problem is from AIIMS 2012. A rod of length 10 cm lies along the principal axis of a concave mirror of focal length 10 cm in such a way that its end closer to the pole is 20 cm away from the mirror. The length of image is. So clearly in this case we may say that it's a case of longitudinal magnification, and also the one end of rod lies on the center of curvature, so the image of that end, which is denoted by 1, will be formed at the center of curvature. Now we will form the image of the end 2. So for end 2 we just write u is the distance of object, and it is equal to minus 20 minus 10, that is minus 30 centimeter, and f is equal to minus 10. So if I apply the mirror formula, 1 by v plus 1 by u is equal to 1 by f, then 1 by v plus 1 by u is minus 30 and minus 1 by 10. From there we get 1 by v is minus 1 by 10 plus 1 by 30, that is minus 3 plus 2 plus 1, that is minus 2 by 30 and minus 15. So clearly the image will be formed at the second image is formed at this point, and again the image will be formed in erected way. So the image will be formed in this way. We call it 2 dash and it is called as 1 dash. So the length of image will be equal to length of image will be equal to minus 20 minus minus 15, that is minus 20 plus 15, that is equal to 5 centimeter. So clearly the length of image is 5 centimeter. And if you see the option, then option first is correct. Now the next problem is from AIIMS 2009, and this formula is based directly on the concept we have learned. that in a concave mirror an object is placed at a distance d1 from focus, image is formed at a distance d2 from focus, then the focal length of mirror is. And we have already learned the Newton formula, in which if a distance of object and image is measured from focal point instead of pole, then the focal length of mirror f is the square root of distance x1 into x2, where x1 is the distance of object from focal point, that is x1 is the distance of object from f, and similarly x2 is the distance of image from f. Then f is equal to square root x1 and x2. So if we apply this formula here, then clearly the option A is correct, that is the focal length of mirror is a square root d1 into d2. Now the next problem is also from AIIMS 2009. A short linear object of length L lies along the axis of concave mirror of focal length f at a distance d from the pole of mirror. The size of image is. So clearly it says that it's a short linear object and the length of object is L and it lies along the axis of concave mirror. So we have to consider the horizontal magnification, or we have to consider the longitudinal magnification, and as this is a short linear object, so simply we apply the formula dv by du is equal to minus v square by u square, which we have learned. So where dv is the size of image and du is the size of object. So clearly the size of object is given here L, so dv is equal to dv by L is equal to minus v square by u square, and here f is given and u is given. U is equal to minus d, f is equal to minus f. So from there we get dv by L is equal to minus. Now if we change this formula in terms of u and f, then it's a f square divided by u minus f square. So from there we get equal to minus, and f square divided by u is equal to minus d. So d minus d minus minus plus f whole square. So we get f square divided by d minus f square. So from there we get dv by L is equal to f square divided by d minus f square with a negative sign, and we get dv is equal to L into f square divided by d minus f square. Now if you consider the magnitude only, because you have to, the negative sign signifies that the image is inverted, or the size of image is inverted with respect to size of object. So if we consider the magnitude only, then the size of image is equal to L into f square divided by d minus f square, and if you see the option, then option C is correct. Now the next problem is a luminous point object is moving along the principal axis of a concave mirror of focal length 12 cm towards it. When the distance when its distance from mirror is 20 cm, its velocity is 4 cm per second. The velocity of image in centimeter per second at that instant is. So we have already derived the formula that the velocity of image, that is dv by dt divided by du by dt, which is the velocity of object, and it is equal to minus v square by u square. If you don't remember this formula, then you just remember mirror formula, 1 by v plus 1 by u is equal to 1 by f, differentiating with it with respect to time, considering focal length as constant, we get minus v square dv by dt plus minus u square du by dt and it is equal to 0, and in this way we get this formula. This is called as the velocity magnification, that is mv is equal to minus v square by u square. Now the problem says that object is at 20 distance from the pole, then its velocity is 4 meter per second. So in this way we may say that the object distance is given. So u is equal to minus 20, f is equal to minus 12, and we know that the v by u is equal to f divided by u minus f. So from there we get v by u is equal to minus 12 divided by minus 20 plus 12, that is minus 12 divided by minus 8. So it's 3 by 2. So clearly in this case the velocity magnification mv is equal to minus 9 by 4. What the negative sign signifies? Negative sign signifies that the direction of movement of object and image are opposite to each other. Now if we consider the movement towards the mirror as a positive sign, so like if we consider this direction with a positive sign, then dv by dt divided by plus 4 centimeter per second is equal to minus 9 by 4, and dv by dt is equal to minus 9 centimeter per second. So negative sign signifies that the image is going away from the mirror. So the velocity of image in centimeter per second is 9 and it is away from the mirror. So option C is correct. Now the next problem is the sun having diameter d subtend an angle theta radians at the pole of a concave mirror of focal length f. What is the diameter of image of sun formed by the mirror? So the figure pertaining to this problem is, this is the concave mirror, and as the light ray is coming from sun, it is far away. So the image is formed, the image of sun, suppose this is the sun, so the image of sun is formed at the focal point. So the image of sun is formed at the focal point. Now you have to calculate the diameter of image of sun formed by the mirror. So this is the diameter of image of sun formed, and this image is formed at the focal point. Now this is the angle subtended by this light ray. So clearly as this object is formed, so if I apply the mirror formula, 1 by v plus 1 by u is equal to 1 by f. So u is infinity, we get 1 by v is equal to minus 1 by f, and v is minus f. So image is formed at the focal point. Now the image at the focus, it is inverted and real, and for a small size of image we may write that theta is equal to L by R. If this is theta and this is the length L, this whole length is L, then as we know that in case of, if this is a theta, this is R, this is L, then we know the relation for a small size of this L. For L very small, we can calculate theta is equal to L by R. So in this way we can write theta is equal to d by f. So theta is equal to d by f and d is equal to theta f. So the diameter of image of sun formed by mirror is equal to f theta. So to calculate the diameter of image of sun formed by the mirror, if theta is given in degree, then first calculate the angle theta in radian, and you have to use this formula. Theta in radian is equal to pi by 180 into theta in degree. So if theta in degree is given, then first calculate theta in radian, then multiply it by the focal length to get the diameter of image of sun formed by the mirror. If we draw the ray diagram for this problem more precisely, then this is our concave mirror, this is the focal length, this is the center of curvature, and a light ray is coming making an angle of incident I. This is our angle of refraction R, such that I is equal to R is equal to theta by 2. Again the other parallel light ray will come, and after reflection it will follow the same path. So if you see here, the image is formed at the focal length. This length of this image is d by 2. The length of this image is also d by 2. So in this way the ray diagram can be drawn. A rod of length 10 cm lies along the principal axis of concave mirror of focal length 10 cm in such a way that the end further away from the pole is 20 cm away from it. Find the length of image. And this problem is very easy. If you see that the one end of rod is at the center of curvature, so the end of rod denoted by A is at center of curvature. Its image is formed at A at the center of curvature only, while the end B is placed at the focal point, and so its image will be formed at the infinity. So clearly UA is equal to C, and VA is also formed at C, while UB is at focal point, then VB is equal to infinity. So clearly here the length of image is infinity, and it's an infinitely large image. Now this is a very good problem, that in a figure shown, find the total magnification after two successive reflections, first on M1 then on M2. So two successive reflections, first is on M1 then on M2. So we will solve it for M1. We will calculate for M1. So for M1, U is equal to minus 30, F is equal to minus 20. So we will first calculate the value of V, and by using the formula 1 by V plus 1 by U is equal to 1 by F, and 1 by V plus U is 1 by minus 30 is equal to 1 by minus 20. So from there we get 1 by V is equal to minus 1 by 20 plus 1 by 30, and it's equal to, so LCM is 60. So minus 3 plus 2, that is minus 1 by 60. So V is equal to minus 60. So clearly its image is formed at a distance equal to minus 60, and it's a 60 from this pole P1, so on the left hand side. So this is the 40, and this here the image will be formed. So we call this image as V1. So we call this image as I1. So V1 is equal to 60 centimeter, and the distance of this image is here, its a distance is 60 centimeter. Now we consider the reflection from this mirror M2. For M2, this object distance is equal to, so we write it U2, and U2 is equal to plus 20 centimeter. So we have to consider the object distance from this pole of convex lens, that is P2, and again I1 serve as a object for this convex lens. So if I draw the ray diagram, then the ray diagram will be like that. So it goes here, and it must be good now. Again, as this object is placed, or this object is placed at the center of curvature of this convex lens, so image is also formed at the center of curvature. So we calculate it also, that U2 is equal to plus 20 centimeter, F is equal to plus 10 centimeter, and if you apply the mirror formula 1 by V plus 1 by U is equal to 1 by F, then 1 by V plus 1 by U is 1 by 20 is equal to 1 by 10. So 1 by V is equal to 1 by 10 minus 1 by 20, that is 22 minus 1 by 20. So the image is also formed at this distance. So V is equal to plus 20 centimeter. Now you have to calculate the magnification. So magnification M is equal to object distance by image distance along with negative sign, that is M is equal to minus V by U. So this is the formula of transverse magnification. So here V is equal to plus 20 and U is minus 10. If you see this object distance, it is 10 centimeters. So U width is minus 10. So from there we get minus 2, that is plus 2. So the magnification in this case is plus 2. So if the object is placed in this way such that the image is formed first from the reflection from mirror M1 and then from mirror M2, then the magnification observed in this case is plus 2. Square ABCD of side 1 mm is kept at a distance 15 cm in front of a concave mirror as shown in figure. The focal length of mirror is 10 cm. The length of perimeter of its image will be. You have given 4 options. You have to pick the correct one. Now so this is the concave mirror M, and if you see that a square ABCD having side 1 mm is kept. So this is the focal length F, which is the 10 centimeter, and clearly the object is placed in between focal length and center of curvature. So the image will form beyond the center of curvature and it is the erect image. So this is the image. So the image will be formed in this way. And in fact, if you see here, the image will not be a square. So if it is 3D, then it will be D dash C dash, and this must be equal to B dash A dash. So see the side which I am writing here, as the CD is close to this mirror, so D dash C dash will away from mirror, and similar with the AB, and again the image will be inverted. An inverted image will be formed. That's why I am showing an inverted image. Now if we apply the mirror formula, then 1 by V plus 1 by U is equal to 1 by F, and for this if we take U is equal to 15 centimeter, so U comes with a negative sign here, and then 1 by V minus 1 by 15 is equal to 1 by F. F is also equal to minus 10. So from there we get 1 by V is equal to minus 1 by 10 plus 1 by 15, and it is equal to 30, and minus 3 plus 2, that is equal to minus 1 by 30. So this image distance is equal to 30 centimeter. So this is 30 centimeter. Now if you see that the height of this image C dash and D dash and A dash and B dash will be calculated by using the concept of transverse magnification, while the object AD and BC is placed along the axis. So the height or the length of image A dash C dash and B dash D dash will be governed by longitudinal magnification. So transverse magnification MT is equal to minus V by U, and it is minus 30 by minus, so it's a minus 30 divided by minus 15, and its value comes equal to minus 2. So if I take the magnitude, then magnitude of transverse magnification is equal to 2. So from there we get A dash B dash is equal to 2 into AB, and it is equal to 2 mm. Similarly C dash D dash is equal to 2 mm. Now if you see the image, then it's written, so it's written wrongly. It must be equal to A dash, this must be equal to B dash, as the image will form, inverted image will form. So BA will form as A dash B dash. So now for the calculation of longitudinal magnification, that is for calculation of A dash D dash and B dash C dash, for this we use the concept of longitudinal magnification, that is ML is equal to magnitude of ML is equal to magnitude of MT square, and is equal to 2 square, that is equal to 4. So A dash D dash is equal to 4 into AD, and it is equal to 4 mm, and similarly B dash C dash is equal to 4 into 1, that is 4 mm. So the perimeter of a rectangle A dash, B dash, C dash and D dash is equal to A dash B dash plus C dash D dash plus A dash D dash plus B dash C dash, and it is equal to 2 plus 2 plus 4 plus 4, so it is equal to 12 mm. So if you see the option, then option C is correct and answer is C, 12 mm. So how you solve this problem? You just separate transverse and longitudinal magnification and calculate both magnifications, then add the sides of a rectangle. So if you see here, as A dash is equal to A dash B dash is not equal to A dash D dash, so it's a rectangle, and the square, the image of a square formed as rectangle. The only case, if the suppose that this square is placed at the center of curvature, so if the square is placed at the center of curvature, then the image will also be formed as a center of curvature, and in this case the image will be the image of an square will be a square itself. So otherwise, for any other position, the image of a square will be a rectangle. Problem number 13. A point object at 15 cm from a concave mirror of radius of curvature 20 cm is made to oscillate along the principal axis with amplitude 2 mm. The amplitude of its image is, so object distance U is equal to 15 cm and focal length F is 10 cm, and again the amplitude is equal to 2 mm. So object size of object O is equal to 2 mm, and as the object is moving along the principal axis, so we have to consider the concept of longitudinal magnification. So the object oscillate between these 2 points A and B, so clearly the image will be formed along beyond the center of curvature, and this is the amplitude of oscillation. So this is B dash, this is A dash. Now how will you solve it? First we will calculate the longitudinal magnification, and for this we first calculate the value of V, and 1 by V plus 1 by U is equal to 1 by F, and from there we get 1 by V minus 1 by 15 is equal to minus 1 by 10. So 1 by V is equal to minus 1 by 10 plus 1 by 15. From there we get 30 minus 3 plus 2, that is minus 1 by 30, and from there we get the transverse magnification is equal to minus 30 divided by minus 15, and it is equal to minus 2. So longitudinal magnification ml is equal to, if we take the magnitude, then magnitude of longitudinal magnification is equal to minus 2 square, and it is equal to 4. So clearly the amplitude of image will be equal to, I is equal to 4 into amplitude of object. So it's a 2, and from there we get 8 mm. So answer will be 8 mm. If you see the option, then option C is correct. So this is the quite easy problem. If you see the problem of 14, it is similar to the previous problem, and here the particle is moving along the center of curvature with the same amplitude, so with a small amplitude A. So as the object is at center of curvature, object distance U is equal to 2f, so the image distance is also equal to 2f, and in this case transverse magnification is 1, longitudinal magnification is also equal to 1. So the amplitude of oscillation of image will be equal to amplitude of oscillation of object, and amplitude of oscillation of object is A, so amplitude of oscillation of image will also be A. So option A is correct. Problem number 15. The distance of an object from the focus of convex mirror of radius of curvature A is B, then the distance of image from focus is. You have given 4 options, so we will solve this problem by two method. First is our conventional method, and second is the by using Newton formula. So first we draw the figure and then we will solve it from the conventional method. So this is the our convex lens, and this the focal length of this mirror is, so this is our the focal length of this mirror is so this is convex mirror. The focal length of this mirror is A by 2. The distance of object from focus of convex mirror is B. Suppose the object is placed at this location, then this distance is equal to B. So the distance of object from pole is B minus A by 2. Now an image is formed between pole to focal point. So we will calculate the value of image distance, and by using this formula 1 by v plus 1 by u is equal to 1 by f, with u is equal to minus b minus a by 2, f is equal to a by 2. So 1 by v minus 1 by b minus a by 2 is equal to 2 by a. So from there we get 1 by v is equal to 2 by a plus 1 by b minus a by 2. It is 2 by a plus 2 by 2b minus a. From there we get 2 into 2b minus a plus 2a, that is, if I take 2 common, then 2 by a into 2b minus a, and it is a plus 2b minus a. So clearly it's 4b divided by a into 2b minus a. So v is equal to a into 2b minus a divided by 4b. So this is the value of v. So the image distance from focus, image distance from focus, the image must be formed somewhere between pole and focus. So suppose this is the point of image, we call it I1, then image distance from focus is equal to a by 2 minus a into 2b minus a divided by 4b, and it is equal to, if I take 4b common, then it's equal to 2ab minus 2ab plus a square. So it comes equal to a square by 4b. So the image distance from focus comes out to be a square by 4b. If you see the option, then option C is correct. Answer is a square by 4b. Now we will solve it from second method. And as we know that from the Newton law, that if we take the object distance from focus, the image distance from focus, then focal length f is equal to square root x1 x2, where x1 is the object distance from focus and x2 is the image distance from focus. So as per this problem, object distance from focus is b and the focal length is a by 2. So a by 2 is equal to square root b into x2, and from there we get bx2 is equal to a square by 4 and x2 is equal to a square by 4b. So the image distance from focus is a square by 4b. So option C is correct.